Good afternoon, boys and girls. Good to see everybody again. And I hope you all staying safe, washing your hands, putting gloves on when you go out, putting masks on when you go out, and just making sure that you try to find some time to enjoy your family and learn a little something at the same time. So today we have another word. You know, we've been working on this equal parts. That was the first video. The second video, when we went from equal parts, we started talking about fractions, which dealt with equal parts because remember, a fraction is part over a whole. So now this week, we're going to be working on something with fractions, but it's a little different. We're going to be talking this week about equivalent fractions. Equivalent. So I'm just thinking about a word that I hear in that word equivalent. So a word that I hear in there will be equal. But we're going to be talking about equivalent fractions, a little different from just being equal. So here we go. Equivalent fractions, I'm going to give you the definition, and then I'm going to show you, because I always say showing is the key to knowing. Equivalent fractions. Equivalent fractions are fractions that have the same value, but have different numerators. And what's a numerator? Is that the top number? Yeah, numerator is the top number. Oh, so if I was to look at something like this, would 24 be the numerator or would 12 be the numerator? You said 12. That's why y'all rock with our church students, because y'all super smart. And you said 24 will be the what? The denominator? Man, when I tell you, I already told you were super smart. I just needed you to see it for yourself. Different numerators and denominators. Different numerators and denominators. Equivalent fractions, same value. Now, what does that mean? I'm going to show you something. Everybody take a look. Baking pans. Obviously, you know, I love cupcakes and cakes and stuff. You know, Mr. Key eat too many sweets. So here's a cupcake pan. And I'm going to count these out first. So you see this piece of tape here? You're probably wondering why do I have a piece of tape here? You'll see in a minute. So I'm just going to count this out. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I have a piece of tape. This piece of tape. What is this piece of tape for? How many do you see on this side? You see 1, 2, 3, 4, 5, 6. How many do you see on this side? 1, 2, 3, 4, 5, 6. So this is in the middle, which is the halfway point. So if I said I wanted you to bake half of the amount of cupcakes that could go in these pans, how many would that be? Half means the same on one side as it is on the other. So if I was to bake only half the cupcakes, it would be 1, 2, 3, 4, 5, 6 that I'm baking out of a whole of 12. Part of what I'm baking is the part, which is the numerator, that's going to be 6. The whole thing is 12, and this is the same as half. Same value is half. So everybody take a look real quick. Numerator is 6. That's how you represent it in numbers. The denominator, which is the whole part, that's 12. Half, I'm only baking half, which is 6, and that equals 1 part out of 2 parts. You got to split these in sections. So this is 1 part out of a total of 2 sections. Equal value. Equal value. This is half. Now think about it. 6 is half of 12, isn't it? 1 is half of 2. Same value. So this is what you would call equivalent fractions. Equivalent fractions. Let me show you another one. Uh-oh. Now this one's a big one. See, Mr. McKee would love me to bake all these cupcakes. It's a lot of cupcakes. I could do it. And if I could bake all these, I could eat a lot of cupcakes. So let's count, see how many cupcakes I could actually eat if we was to bake all this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Man, If I eat 24 cupcakes, I'm gonna be in trouble. But I sure would try. Well, I have a piece of tape here too. So they said, Mr. McKee, you can't bake 24 cupcakes. I'll let you bake half. Well, let's see. Half means the same on one side as it is on the other. And I got to split down the middle. So half would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 cupcakes I can bake out of a total possible of 24. So what's the numerator? You said 24? You sure? You sure? Remember, 24 is all the cupcakes I could bake. Oh, you said, Mr. McKee, I'm sorry, I made a mistake. It's 12. Oh, you say 12? Okay, that's right. Because 12 is the part that they said I could bake. 24 is the total possible. 12 is the part that I can bake. So it's numerator 12, denominator, which is the whole thing, 24. What is this though? What's another way to represent this? It's half of the whole thing. So let's see how it looks in numbers. Isn't that 12? That's how it looks in fraction form. That's 12. That's the amount of cupcakes they said I could bake, and I probably eat all 12 out of the total that I could, which is 24, which is the same as 1/2. So hold on, let's see now. It's 2 sections. I just broke them up into 2 sections. Sections of 12. So this is 1 whole section that I can bake out of 2. I want all, but they only told me I can do half. All right, so that's equivalent fractions. But I'm not done yet, because see, there's other things that you need to know about equivalent fractions, and I want you to be able to see it for equivalent fractions in different shapes and different ways of doing it. So just pay close attention. Pay close attention. So let's see here. I have 3 different looking fractions. They have different numerators and different denominators, but they have the same value. So starting off with 1/4, you guys have seen this before because you've been in fraction. You had all these great teachers, Miss Franklin, Miss Wilson, Miss Adams, you had Miss Bogan, you had Miss Wiseman, and you have seen all of this wonderful fraction stuff before. So 1/4 means, okay, what does that mean? I have 4 sections, and out of those 4 sections, that's total of 4, I have 1 section, part of that 4 is shaded in. Okay, make sense? Okay, let's take a look here. I have 8 sections, 1, 2, 3, 4, 5, 6, 7, 8. Notice I have these blue lines because I wanted to show you how this looks similar. But this is 8 sections, and out of these 8, I have 2 sections shaded. Notice these sections get a little smaller, and I have 2 out of 8 shaded. And you're going to see all the connection in a minute. I think you already are seeing it, because here at Robert, our church, we just got it like that. We just got it like that. So now this one is, we still have 4. It looks like this thing still is in 4 sections, but I split each one of these sections up into 3 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in this part, I have 3 sections shaded out of 12 sections. But wait a minute. You already said, Mr. McKee, I see similarities. This one section looks like the same as this one section, looks like the same as this one section of shade. So you mean all of these is just really 1/4 of the sections. Think about it, because really I still only have 1, 2, 3, 4 sections. 1, 2, 3, 4 sections. I just split each section up here into 2 parts, right here, right here, and right here. I split each one of these sections up into 3 parts, right here, right here, right here, and right here. But it's still 1/4 of the total sections that are shaded in. So all of these are equivalent, same in value. Now they look different though, but it's the same in value. It's still 1/4 of that particular section. Now let's take a look. This one's a rectangle, so a little different. I have 1, 2, 3 parts, which means I have 1 shaded in out of 3. I have 1, 2, 3, 4, 5, 6, and I have 2 shaded in out of 6. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have 3 parts shaded in out of 9. Wait a minute. Mr. McKee, all of these kind of look similar because this one is one section out of three, but I'm still seeing one. And notice this though, I still have sections. I just split this down the middle. If I drew a line down here, that just made this into 6 parts. And I drew 2 lines right here, which split this into 9 parts, but it's still only one section out of 3. So this is 1, 2, 3. This is one section of 2, 2 sections of 2, 3 sections of 2. This is one section of 3, 2 sections of 3, 3 sections of 3. And each one of these only has one section shaded. So it's still equivalent to 1/3. I didn't say equal. I said equivalent because it's the same value, 1/3. But it's not equal, it's equivalent because it's the same value. Because if I was to say I ate 1 out of 3 candy bars, that may not look the same as these, but it's equivalent, it's same value. Same value, equivalent fraction, same value. Now, one last thing, and I'm going to take a little pause because I want to show you how this all works. So give me a few seconds and I'll be back. Commercial break. Hey, I'm back. I told you commercial break. Did you get the commercial? No, I was just giving you a little think break, think time. I had to go grab some markers. Now, take a look. I got to show you guys something because, see, you understand equivalent fractions. That's the same value, different numerators and denominators. If you notice here, different denominators, different numerators, same value, different denominators, different numerators, same value. Now I'm going to show you kind of a slick way because, see, some of you are very good with just looking at shapes and seeing all the shaded in and noticing that they're the equivalent fraction part of it. But what if I was to show you a mathematical way of being able to do the same thing? I'm going to step over here. Everybody take a look. This right here is 1/4. This is 2/8. Now we found out that these are equivalent. All right? Same value. Check this out though. This represents 1/4. 1, 2, 3. This is 1/4. 1, 2, 3, 4. This is 1/4. This is one section out of 4 sections shaded. Now, this one, notice, is still 4 sections. This is another section. This is another section. And this is another section. Still 4 sections, but I split this section up into 2 parts. Each one of these sections have 2 parts in it rather than 1. 1, 2, 1, 2, 1, 2, 1, 2. Now, if I was to compare these two, this is 2 more sections. This is split into 2, so this is 2 times more sections than this one. This is only 1 total section. This has been split into 2, so this is double now what we had here. So this is times 2. So if I was to say, how would I get from here to here? Times it by 2. Now you got to understand, if I double one section by 2, that means that this whole thing, each one of these sections is doubled by 2, which means times it by 2, and you get 8. So what's double 4? If you double 4 or times it by 2, that's going to give you 8. So whatever happens for the numerator, the same thing is going to happen automatically for the denominator, because each section got 2 parts. Each section was split into 2 parts, but we doubled it. Double the top, double the bottom. If you understand, then you got it. All right, now let's move on. Let's go to the next one. So if you notice, one section here, shaded. I went here, same thing. Now let's take a look. This is one section, 2, 3, 4. Same here. One section, 2 sections, 3 sections, 4 sections. Now, the difference is I split this section up into 3 parts. 1, 2, 3. I split this section into 3 parts. 1, 2, 3. I split this section 3, into 3 parts. 1, 2, 3. Same thing here. 1, 2, 3. So each section has 3 parts. Now check it out. That means that I tripled, or I have to multiply by 3 for each one of these sections. So 1 times 3. because I tripled. Triple means 3. So if I say triple threat, that means 3. So here we go. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So if what did I do? Went from 1 section to 3 sections, 1 part to 3 parts. Guess what? Times it by 3. But remember, if I'm going to triple each one of these sections, I had to do the same thing here. So whatever happens to the numerator happens to the denominator. I did what? Split into 3 more parts. Triple for each. So guess what? I do the same thing for the denominator. So now let's try this. That makes sense, folks? That makes sense, everybody? Thumbs up. Everybody say hooray. Okay, Robert Out Church way. Here we go. All right. Here we go. Now let's try this. So 1/3, what would I have to do to get to 2/6? That means if I'm looking at the numerator, this is double this. So that means if I just times this by 2, wait a minute. But remember, if I double the numerator, look at this 3 and this 6. What do you notice? Oh, what? 6 is double 3? So you mean times it by 2 as well? Whatever you do for the numerator, you have to do for the denominator. Let's try this next one. So this is 1, and this is 3. This is 3, and this is 9. So to get to 1 to 3, that means I would have to triple this or times it by 3. And whatever you do for the numerator, you must do for the denominator. And so that means I would have to multiply this by 3 in order to get 3/9. Equivalent in value. Same value, different denominators, different numerators. Same value, different denominators, different numerators. Equivalent fractions. Part over whole equals a fraction. Equivalent fractions. I hope that you have learned something from me today. Remember, we love you. We love our neighborhood, 38116. Please be safe. Look for me next week about more fractions.